Well, hello, good day, everybody. My name is Scott Cortier from InduSoft. I'm the Marketing Communications Manager. And today we're going to present about oil and gas and how you can use InduSoft Web Studio in the oil and gas industry. And today we have a guest speaker, Mr. John Luttringer from Genesis RTS. He's the Chief Technology Officer, and he'll be co-presenting with myself. And we'll cover some of the ideas and concepts that on how you can use InduSoft within the oil and gas industry. John will cover some of the different facets of the oil and gas industry. And then we'll open it up for questions and answers at the end. So feel free to post in your chat window or the Q&A session of the WebEx session. And feel free to do that during the presentation or at the end when we open it up. And we'll try to get answers to your questions. So let's get going here. And again, thank everybody for your time. Also, one of the things I'd like to mention is don't forget to sign up for the or fill out the survey that you'll receive after this webinar, and that will allow you to receive your free t-shirt and give us a little bit of feedback on how we're doing and other topics that you'd like to see on this webinar as well. Also, the slideshows and the video recording of this will be posted in just a few days, so you can come back and take a look at it if you need to. So within InduSoft, let's start a little bit by talking about the company. What is InduSoft? For those of you who are not familiar, I see a few names that have joined the WebEx that I don't necessarily recognize. So let's cover a little bit about InduSoft, the company. We were established in 1997 in the U.S. And really our product is HMI and SCADA software. We're a software-only company. And for those of you who know us as HMI or SCADA, maybe you don't know us as the other side of that coin, so to speak, where we get involved in very, very low-end human-machine interface type applications, down as far as we support down to 150 tags licensing, and all the way up to now we go up to 10 million tags in our licensing, and several different layers in between or levels in between. So if you are maybe more familiar with us as an HMI provider than a SCADA company, please realize that we have all the feature sets that you could ever possibly want for SCADA product, and then the converse is true too. For those of you who are familiar with us as SCADA, maybe large monitoring systems, we do also do very low-end systems as well. And the nice thing about the product line is that the feature set is the same across all those different license levels. So you don't have to be concerned with, well, if I change to this, do I get that product within my license or not? So a little bit quickly about the product. We were pioneer in the industry, first to have an HMI or SCADA package for Microsoft Windows CE, and that was back in the late 90s, 1997. And what that's done is that's allowed us to keep our mind on making the product efficient and as quick as possible and as small a footprint as possible, and that translates into our full-blown product as well, not just on CE. We were the first to have a web solution and XML integration for HMI and SCADA. We also have a patent for our database connectivity that will allow you to connect Windows CE and embedded devices that would not normally be able to connect to certain types of databases. Allows you to be able to do that. So we have a patent on that connection mechanism. We're a Microsoft Gold certified partner. And we've also been a member of the OPC Foundation since the late 90s, I believe 1998. And you can see some of the other certifications and company solutions that we've been involved with too. We also have numerous awards. One of the ones I would like to point out is most recently is the 2012 Control Engineering Engineer's Choice Award here, and I'd also like to mention that we're up for nomination again for the 2013 awards. So if you're a Control Engineering Magazine subscriber, please go to their website and vote for us. This year we have 3 products that are in the running: the InduSoft Web Studio product, the Business Intelligence Dashboards, and our Mobile Access product offering as well. So where do we have offices? We're headquartered based in Austin, Texas, beautiful Austin, Texas, down in the southern United States. We also have 2 offices in Brazil and an office in Germany as well. And as you can see here, we have distributors, reps, and partners throughout the world. So if you need support, sales information in your region, we probably have it across the globe. So what markets is InduSoft in, and why does this pertain? Why am I even showing you this in an oil and gas webinar? Well, InduSoft is in many different markets, including oil and gas, and I would typically say that this and others is just as important as any of the other slices here in these different industries, because not only we're in just these industries, we're in just about any industry you can imagine. So why am I showing you this? Just as an example, we build InduSoft Web Studio and have a common feature set across the entire product range, and really there is, if you can think of it, only one product where everything comes included, not only graphics, but animations, alarms, trending, reports, database connectivity. And when we get requests from one industry, and if it's specific to that industry, it probably can be used in another industry. To give you an example of pharmaceutical industry, there is a U.S. government requirement called 21 CFR Part 11, or FDA 21 CFR Part 11, and they by implementing that, it allows the HMI or SCADA application to have features in it that will allow users and passwords and logins and security, as well as traceability and the ability to let's say, for example, challenge a user if maybe a supervisor has logged in and walked away. If a standard operator comes in and tries to use the supervisor's login, it will challenge them again. So, as well as traceability options. So, those types of features that maybe have been pushed on us by other industries, and we've welcomed and added those into the product, you get to take advantage of those in your particular industry here. And other industries like that have asked us to add features, so you'll probably see some of those and be able to take advantage of those as well. Some of the features that you may find that might be related to oil and gas applications, I list a few here. I have one more page. I'm going to walk through a few of these on the actual product itself. I'll give you an example. Driver sheets can be triggered on an as-needed basis, and this might be beneficial for remote or leased line applications where there might be a charge for the amount of data that you transmit and receive. So what do I mean by driver sheets can be triggered on an as-needed basis? Let me switch over to our development environment. Now, what I've done here is I've created an application that's brand new, and I'm going to install a driver here. Now, I'm going to install, let's say, Modbus TCP driver. It just happens to be one that I'm familiar with. So I'll do this here. And the Modbus TCP driver is one of the 240 drivers that we have built into the product that allow you to connect to really just about any PLC, DCS, motion control, barcode reader, things of that nature, temperature controller, just about any type of device that you could imagine. And if we don't have that, I'll show you a little bit later how we can configure and use OPC as well. So here, when we first install a driver, we're presented with what's called a main driver sheet. Now, the main driver sheet allows you to put a tag name in here. That's what you would use within InduSoft, and then an I/O address that might be in the PLC or whatever controller you're using. You can also point to the PLC via the IP address, and whatever station addresses can be used. And we also offer the flexibility here that not only can you type in and hard code, so to speak, the IP address, but you can put a string type tag in this field, put curly brackets around it, and then you can change the IP address of what PLC you're going to during runtime. So that adds quite a bit of flexibility into it. But this main driver sheet, while it's very easy to use, and one of the benefits that it offers is the ability to put any I/O address in here, and you can mix and match the memory types that you go to in the PLC. It has a fixed scan rate of 600 milliseconds. Now, you do have the ability to disable this worksheet whenever you want to, but it has a default scan rate of 600 milliseconds. So what if you want some flexibility to be able to trigger the driver communications when you want and when you choose. Well, at that point, what you would do would be to insert what we call a standard driver sheet. You can see here the main driver sheet just up here in the header has this 4 fields for status, where here in the standard driver sheet you have not only those 4 fields for status, but now you have the ability to put tag names in here to trigger this driver worksheet when you so choose. And so it's a lot more flexible, a lot more powerful. And what you might do is, using this these triggering fields, toggle a tag at whatever rate you want to choose. And you can do something like set this up in our scheduler here under the Tasks tab. I'll right click here, and you can see that there's 3 different types of events. And if we choose the calendar event, then you use this time and optionally the date field. If you use the time field under the calendar, the time field is a time of day. So let's say you wanted something to happen at 10 p.m. at night. You would put in hours, it's 2200 hours, minutes, and seconds, and optionally a date field in here, but more than likely you're going to have just the time of day. And then you would put something like trigger tag, and because that doesn't exist, I'm going to create that. I might put that as a boolean, and then in the expression I would put not trigger tag, and that would allow me to toggle that tag at 10 p.m. at night. Then I would go back in and put this in the standard driver sheet in here, maybe in the read or the write trigger, and that would allow that to trigger. I also see people putting array tags and putting multiple standard driver sheets and allowing them to flexibly configure those and fire those off when they need to as well. Another thing to point out here in the calendar, when the event is calendar, this field time is the time of day. When the event field is set for clock, this time field changes its nature a little bit, and it's a period or a frequency. So for example, it's still the same format, hours, minutes, and seconds, and in this case maybe I would have something that would fire off every 15 minutes instead, and then use a similar but a different tag here. And then if I wanted to trigger communication to happen every 15 minutes, or even more frequently than the 600 millisecond default from the main driver sheet, you can do that as well. So those are just a couple of options that you can use here for the driver sheet configuration. And again, for remote or leased line applications, something you might have over a microwave radio modem or satellite connection, where I don't know the rates, but I can imagine that those are relatively costly, and you might not want to communicate all day long, every day at 600 milliseconds. You might want to decide when you want to trigger those applications or to communicate. Thin clients, InduSoft Web Studio supports 3 different type of thin client applications where you can view on up to 128 remote stations, whether it be Internet Explorer or using our secure viewer software to be able to view and interact with the screens remotely, or our third type of thin client, which is called Studio Mobile Access, or now just Mobile Access, whereas now on any HTML5 compatible browser you can use InduSoft Web Studio or the thin client to see back to InduSoft Web Studio and interact with the tag values, process values, alarms, and trends. And you can do that on iPads, Android, tablets, and phones, or any HTML5 compatible browser. It could be Firefox, Chrome, could be the new Internet Explorer 10 in Windows 8 as well. In addition to that, we have email and text messaging, and it's pretty easy to set up in InduSoft Web Studio. As far as setting up the connection to an SMTP server, that's all you have to do now is go into Project, go here under Email, set up your usernames and passwords and things of that nature, and make sure this checkbox is checked that it will configure this when starting up the runtime. Alternatively, what you can do is cause this to reload and put some tag names in here, or we have a scripting function that can allow you to change these settings during runtime as well. Once you have that configured, then various places within the product, including scripting, you can set up, for example, here under Alarms, to enable automatic sending of email, sending based on triggering events. Right now we have that set up every minute. That might be a little bit frequent, but that might be relevant to your application whenever you have any alarms coming out. But you can trigger those however you'd like to. And you can also use the email capabilities to send text messages or SMS text messages as well. Most of the carriers have a phone number or an email address that you can set up, send text messages to, actually send an email to, and it will forward that on as a text message. And we have a very nice blog post on all the different carriers and all the different email addresses that they support and how to handle that as well. Another thing to bring up is the ability to add security to the emails. This Enable SSL checkbox now allows us to use accounts like Hotmail and Gmail with our email system, so that you can get access to those free email accounts that you might have associated with your particular application or process. So continuing on, connections over radio modems or satellite is something we can do built into the product. We have a few different examples of how to configure emails on our sample applications that you'll find in our DVD, and you'll also find those on our website as well. Trending and alarming are very big components that you'll find in the oil and gas industry. We have demos for each of these built into the PC demo product that comes along with the installation of InduSoft Web Studio, and we encourage you to beg, borrow, and steal from that application. Learn from it. It's a very complete demo, and it really shows you how to use the product. Also, don't forget, we have training videos that show you how to use this, and we have an upcoming webinar. We're planning another webinar probably in the next month or so that will cover alarming, and so please come back if you have information or want information regarding alarming as well. Our database connectivity is we can connect to any SQL relational database. We also support redundancy built into the product as well. So again, any SQL relational database, and it doesn't have to be SQL. We can go to Microsoft Access or Excel as well. We can treat those as databases or via other connections, and it's pretty simple to do. Basically, you build this connection string, or you can click on this browse button and let InduSoft Web Studio build it for you, and basically you point to the provider that you want and then give it the information, and away you go. It's pretty easy to do. It's kind of fill in the blank and get you going from there. So for example, if I was to choose a provider here, might be Microsoft Access or SQL Server, and then choose my database. If I happen to have a local database, I would choose local, and then I happen to have a SQL Server Express installed on my laptop here. Choose security level, and then choose the database on this. Maybe I'll go to my database and then test my connection, and at that point it's set up and ready to go. I can use that throughout my application. Now what I just did, I can tell you from experience, about 10 plus years ago I developed an application that used a database, and that step right there took me about a week to do. So the fill in the blank nature is pretty easy to use within InduSoft Web Studio. So let's see. Also, OPC communications. We've made it pretty easy to enable communications for OPC. Now, I mentioned the driver worksheets that we have built in. OPC is optional within InduSoft Web Studio, and what I mean by that is we have the built-in drivers that you can use. You do not need to use OPC to communicate to PLCs or temperature controllers or other controllers, but we include OPC DA, OPC UA, and .NET within the product. OPC XML is available for an additional charge, but again, OPC DA, just about everybody knows is OPC is DA, which is now termed as OPC Classic by the OPC Foundation. John is going to talk a little bit in his presentation about how we can use OPC UA, and what I'd like to point out is just how easy that is. Within OPC UA, we can insert connection, and when we do this, we give this a name. So I might term this OPC UA, and then using what we call a discovery server, I can use the discovery server on my laptop that will go out and find all the possible OPC UA servers that it has access to. In this case, I have the OPC UA sample server available from the OPC Foundation. I'll connect to that, and then it's automatically built everything in there. We had a question in the morning seminar about what differentiates our OPC versus everybody else's, because it is a standard. We have the ability to build in security here. We have the ability to do self-signed certificates, or you can use third-party certificates. We've done an OPC webinar previously, so feel free to go back to our video on that and see how to build certificates for that. Something additional that we have is we are the first in the industry to have OPC UA available on Windows CE, so that sets us apart a bit as well. So now that I have this named connection in here, what I can do is go insert a driver sheet, I'm sorry, not a driver sheet, but an OPC worksheet, and choose the connection that I'm going to use based on this name. Now the way we've done this is this adds flexibility, so as you create additional OPC worksheets, it lets you choose which connection you'd like to use. So if you have different connections, OPC server to different controllers or different PLCs, that's a very nice flexible option for you. Once I've done that, now I'm essentially ready to communicate with the OPC UA server. I can click here on Item and Browse. Now this is coming back from the OPC UA server itself. This is not something generated by InduSoft, so this is actually communicating with the OPC UA server, and I'm going to drill down here into what they have. I'm going to open up an integer value here and point to that data point within that server. Now that could be anything within your process or your application. They just happen to create a demo that's called int16 value. And I'm going to put this as a tag name. I'll just call it value for now. And because that tag does not exist, it's going to prompt me for it. I'll just leave that as an integer. And now what I'll do is I'll go back to the screen, or after I save this, I'll go back to the screens, create a new screen. And here on the screen, I might display that value as just text, and which 16-bit integer value is going to come back as a fairly large number. And at this point I can enable an animation on there to make that a text data display, and so I don't mistype it, I'm going to choose here value. And now when we run this, what you should see is the value coming back from that OPC server, and once we have connection it should start up, and if it doesn't, I'll have to do some quick troubleshooting here. There we go. And so now we're getting that 16-bit signed value coming in from that OPC server. So that really just took a few seconds to enable. Another thing that sets us apart is we do have the ability to copy and paste, to do some export and import from the different servers. So it's very quick to get those item names or tag names in from the OPC servers. So let's see, what else did I want to cover here? So there's OPC communications, database connectivity. So I think I covered all those. Some of the benefits that we have in the oil and gas industry is really lower total cost of ownership, and just really maximizing engineering productivity. And if you've taken notice of InduSoft Web Studio and taken a look at how we develop the product, we try to keep things as efficient as possible and keep things similar or the same depending on how you use features across the product. And things like the properties window, for example, if I have several different objects on the screen, I don't have to open up, configure the properties, and then close the properties every time. I can leave that properties window open and just kind of skim across the surface. So as I have different objects, again, I don't have to close that properties box. Again, saving little keystrokes, little mouse strokes here and there really just adds up over time. The ability to create your own symbols in the symbol library again maximizes your engineering efforts and the ability to share those across your product team. Something else that we have in the product that we started offering recently is the ability to add on a collaboration tool, so that you can use an external tool, which is Microsoft's Team Foundation server, and allow you and multiple of your coworkers to share and collaborate on a project simultaneously. The scalability of the product affords you the ability to develop, let's say, a medium-sized application and then take that and reuse that in a larger, maybe a server SCADA type application, or down to a smaller HMI application, or even a remote application, with supporting many of the the Microsoft operating systems, or all the operating systems from Windows CE to embedded to desktop operating systems such as Windows XP, Vista, Windows 7, and now even Windows 8, all the way up through server editions and even into Microsoft Server 2012 as well. The ability to reuse components of your applications, whether that be driver worksheets, OPC worksheets, or even graphics that you can reuse throughout your application. That just, again, reduces the cost of your engineering efforts and reuse. Remote connections, as I mentioned, not only the changing and the triggering of the driver sheets, but also the ability to get InduSoft onto displaying data and trending and alarming onto phones and iPads and smartphones and tablets. You might not be present at the particular location, but you can certainly see the data, certainly see the information or alarms, and see what's going on, and that helps make you more efficient. And something else is the ability to trend over long periods of time, not just trending a few minutes or a batch, which you can do, but you can trend and log information historically over days, months, years. And I've seen some databases contain over 1 million points of data that we can bring back in on the screen and view. And we also have some tools within the trending that are, for example, if you bring in 1 million points of information into a trend, there's no way that you can see 1 million points on the given screen. There's just not that many pixel resolution. So some of the things that you can do is we have this feature here called decimation, and that will take average samples from your database and make it more efficient, and then allow you to see that on your screen as well. So we can do that, and we can go back into history, whether that be days, months, years, whatever the case may be. So we have that built into the product as well. So there's some things that might be of benefit for you in the oil and gas industry. Here's a couple different real-world applications that we have. These are case studies that you can find on our website or on the DVD. This particular one, VPON Controls, they've taken InduSoft Web Studio and are using it in the cloud to get oil and gas monitoring remotely. So they can do that anywhere. So they put the application up in the cloud, and they can access that from wherever they need to. You can see a couple of different screenshots here. And again, these are real-world case studies where people have customers have implemented InduSoft Web Studio. GZM Oil in Egypt uses InduSoft Web Studio on a platform environment, and there are a few different applications for that. Recently, I spoke with a customer who wants to operate boom cranes on an oil platform, so we can show the animation of the actual crane going up and down as well. And this application is a Windows CE application that we have, and here you can see they're doing PID control and flow rates, and they have these little miniature trends on a handheld PDA device running Windows CE, so they can set different flow rates and set points on there as well. So there's a few different case studies that you can download from our website and see real-world customer applications for that. So what I'd like to do now is hand the presentation over to, again, Mr. John Luttringer. And let's see, we'll unmute him. John, can you hear me?
Yes.
Okay, good. Now, let's see. Now, the one other trick that I have to do is hand the presentation over to you. And let's see if I can do that here. Change your role to presenter. And now you should have access. There you go. So now you can go ahead and share your desktop.
Okay. Does it show up?
Not just yet. Let's give it another second here. There we go.
All righty. Thank you, Scott. This is a presentation that we basically did for the OPC Technology Summit back in October, and I'm going to kind of run through it. So, basically, our experience base. So I'm talk a little bit about that, our vision, current state of the industry, target end state, and follow up with a kind of a summary conclusion. I'll talk a little bit in the target end state about how we're implementing InduSoft from a product point of view in our current architectures. Experience, the company is really a combination of basically some experts in the oil and gas industry and a collection of NASA engineers that have real-time command and control experience. Dr. Eric Van Oord is basically the chairman of the board, former Shell employee, 27 years with Shell. He currently is the professor there at UT. He's heading up the petroleum engineering department there at UT in Austin. And basically, he's basically from a experience point of view has done. Handled all the Shell's offshore drilling for many years, and specializes in synthetic muds and other things. So he has a wealth of experience in the oil and gas, and actually has been very beneficial in educating me. Being my background is software engineering and real-time command and control. So my experience has been working with NASA for a period of years on various shuttle and station programs from a real-time command and control, and also doing things from a remote command and control with offshore oil rigs and also onshore oil rigs. Our vision, opportunities for exploration and discovery below the surface of the Earth are pretty much just as exciting and wonderful as those above it. So we kind of look at from a real-time command and control is the end item changes, whether I was communicating with a satellite or the shuttle versus an actual oil rig. Those end items basically have a different purpose and a different operation, but how you command and control them, there's parallels. There's commands going to them and information coming from them, and your team basically reacts to it. We see basically from our vision that drilling optimization and then completion planning and operations in the energy sector is kind of taking off. And so we're aggressively pursuing that. We're also leveraging current data and information management methods and techniques and tools. And we analyze challenges as opportunities. So if you look at the industry today, the industry basically is just now starting to basically embrace OPC, and in particular OPC UA. It's going to be, from our perspective, an evolution for the industry to go ahead and embrace this. The industry primarily today is dominated by a standard called WITS-ML, and I'll discuss that a little bit later on in the presentation. This is a view of the rig systems, and I'm not going to necessarily go into great detail. I think I did a little bit on the earlier presentation, but I'm not going to go into great detail on this. Just to say that these are the various subsystems of a well, and with each one of these subsystems, there's a purpose associated with them. So I'll give you, for example, the rotary system basically has a top dive or a rotary table, and in the industry terms, a rotary table is called a Kelly. And it basically causes the drill pipe to turn, and it's something that you basically, as a driller, you basically power that on or power that off. With this system, there's a drill string, drill pipe. There's what's called a bottom hole assembly, and then there's a drill bit that's attached to the bottom hole assembly, and that's your primary capability for actually performing drilling. Now, associated with these systems is a set of instrumentation on the rig. Some of it is attached to the rig. Some of it is downhole in the form of what's called MWD and LWD instrumentation. MWD instrumentation is basically a data package that fits within the drill string, and it's downhole, and it's basically measuring measuring things from a downhole point of view. So it can be trajectory of where they are. So if I'm doing horizontal drilling, it'll give me coordinates information about where I'm at in relationship to XYZ coordinate system. also information about depth, those kind of things. So all of this information then basically flows off of the drill rig and is the information that's available to be used from an optimization point of view. This is a picture of basically how kind of the industry is kind of layered out today. So we have basically a well operator here, and you can think of the well operator as a shell. That would be a well operator. They basically have leases for property that they can go ahead and drill on that property, and they go out and do basically a set of seismic surveys on their leases, and as part of the geology team, they basically look and find where within the lease that they have is any potential hydrocarbons there. So they find a potential play. And then as part of that planning thing, then they basically will plan to go ahead and drill that hydrocarbon formation. And that's where you get into the drilling side of the fence. So they start planning for that. They go out and hire a drilling contractor, and that drilling contractor will perform the drilling. And they typically will hire in a drilling services company that provide the list of services that they have here. They don't necessarily contract for all of those. It's usually partial. So I'll talk a little bit about the contractors and the drilling service companies here on the next slide. So contract drilling. So most of the majors contract out all of their drilling, and so some of the companies out there is Transocean, Noble Drilling, Parker Drilling. They basically have fleets of rigs, and they contract out, and it tends to run what I call day rates for rigs. So if it's an onshore rig, it's typically around $25K a day. And if it's an offshore-based rig, it can get in the neighborhood of $500,000 a day or above. And so what happens with that is there's from our perspective, there is techniques and stuff that can be done using real-time data and real-time command and control to basically reduce the amount of time it takes to drill a well. And by doing that, then in turn you have a savings basically at those kind of rate structure from a drilling company point of view. So one of the challenges that we have today is that once a rig is built and added to the fleet, there's really no incentive out there for the basically drilling company to refurbish or migrate the instrumentation and data collection systems to alternative architectures and or standards. And so the rigs that are built today basically have a single serial interface for data. They have instrumentation. That instrumentation is not really updated or augmented from the time that the rig is built going forward. One delta that I would say out of that would be in the case of measurement while drilling data, that is something that's in line to the drill string, and that basically is a downhole package, and that can get changed out on a regular basis as new technology and stuff becomes available. The service providers, they basically have provided customized, tightly coupled solutions to the oil and gas industry, and particularly in the areas of data acquisition systems. So they provide a capability to where they interface with the rig. They'll have a WITSML server. That WITSML server will typically take a serial feed off of the rig. They integrate communications into it. They provide a WITSML data historian that can be either in the cloud or that can be at a particular company site. And then they provide drilling applications for the full drilling life cycle, from initial search for actually hydrocarbons from a set of logs that are available from the logging all the way through the planning phase to the actual drilling phase. And then on the downstream side, once you've found hydrocarbons, the actual completion of the well. They currently have large client bases, and they're pretty much kind of reluctant to and hesitant to change without some form of proven business value that's out there. So we see them as, well, this is working fine for right now. We really don't see a need to kind of move to anything else. And that's been somewhat of an issue with a lot of the customers that we're currently working with, in that they have capabilities, but they don't necessarily want to evolve the capabilities, which provides an opportunity, and so that's what we look at it. Talk a little bit about rig functions. So on an actual rig itself, we have hoisting. That's basically moving the drill string and casing up and down. I'll explain casing just briefly. When you drill a well, you basically have a bore that goes down for a particular depth, and a drill bit has a certain size associated with that. And from a well plan point of view, they will plan on drilling with a certain size bit down to a certain depth, and then they change to a smaller bit at that point in time. And as they drill a well, they have a casing plan, and that is basically a set of steel tubing that is basically drill string or the drill bit is removed from the hole, and they lower this tubing in, and it insulates in between the walls of the well bore and the actual location of where the drill string is going into it. And so it's there to go ahead and protect the well from the surrounding formation. So that's where you get protection for your aquifers and things like that to prevent any hydrocarbons from contaminating those. And so that casing is basically put in from that. So the other functions is rotation, drill string, and then putting the casing in. Circulating, that's circulating fluids in and out of the well. When you drill a well, you're pumping mud into the well. That mud is there from a lubrication point of view, but it also removes the cuttings as the bit is turning in the well and shearing the rock at the bottom of the well. It flows those cuttings out. There's also a well control that is there to control downhole pressures and prevent blowouts. I think everybody thinks of Macondo, which was the Gulf disaster here 2 years ago, and that was really a well control problem that they had. That they didn't perceive that they had a problem and had a bad situation that killed a number of human beings, unfortunately. Operations, there's drilling. Operations, there's drilling. Tripping is a term for basically raising and lowering the drill string out of the hole. Running casing, I talked a little bit about. Cementing is a process that you do after you've run casing. It basically provides a cement layer in between the casing. The casing is a little bit smaller than the diameter of the bore of the well, and so cement is basically injected, and that cement basically fills that location in between the casing and the outer wall of the well bore, and it's there to go ahead and cement that casing in location and prevent it from moving around or any penetration of any type of water or external to it from a formation leaking into the well itself. There's also formation evaluation that has to do with logging. So they'll run a sensor down and they'll do logging at various depths within the well that is currently being drilled or an existing well. Completions, workover, and then obviously there's abandonment of the well when it's all said and done. Well monitoring systems, that basically a set of surface sensors and parameters. There's also downhole telemetry. I talked already a little bit about MWD and LWD. Historically, this has been done through a serial sort of ASCII data transfer, and that basically primarily most of your land-based rigs use basically what's called the Well Site Information Transfer Specification, which is called WITS. And with the new technology that basically is out there, or is this Well Site Information Transfer Standard Markup Language, or WITS-ML. What we see today is typically there's a conversion of WITS into WITS-ML at the rig, and then that data is basically transmitted from the rig to another location. There's various instrument and service providers out there that provide the instrumentation on the rig. Two of the primary ones are Payson and MD Taco, and they basically, when a rig is built, the company that is actually building the rig, they hire an instrumentation provider like Payson or MD Taco. They come in and provide instrumentation for the rig, install it, configure it, and provide the infrastructure so that they can collect data off of the instrumentation, and typically will provide some form of serial interface there to basically collect that data on the downstream side. The data handling, there's data acquisition at the well. Like I say, no direct access currently today to instrumentation, which we see as something that will change over time, especially with an OPC capability. We also see that the rig data interfaces, data acquisition and conversion from WITS to WITS-ML, and then ultimately storage. So that rig interface there, we get the data, we keep a local copy of the rig data on the rig itself, and then basically provide a store and forward capability with that, and then promote that data out to a more of a historian type thing, usually at the corporate office or at in some cloud. And then the WITS-ML server obviously transmits, processes the WITS-ML data, and store and forward capabilities. And basically it provides direct support for applications too as at the rig site itself. So this is a picture of kind of how things take place from a high-level point of view. So we have our rig here and the rig components and the instrumentation. We basically have a serial interface here. Well, we'll just see we have MD Taco instrumentation on here. We have a serial interface. We're basically reading data coming in off this serial interface, and it basically is primarily at about a 1 hertz basis data coming off of it. That data is then collected. We put that data is put into a WITS-ML server. That server communicates through either satellite, could be cell phone, could be microwave. Flows data over to a data historian. That data historian is usually hosted in the cloud. The data is basically organized in that data historian using the WITS-ML standard, which is it's an XML standard, so each well is considered a unique entity, and then the data associated with the well is basically distributed in different formats within our different locations within that architecture. But you start with a well, and then from there you can basically find all the data associated with that well, whether it was MWD data or basically drilling data associated with that well. And then it also provides a interface so that the applications that are used from a beginning well planning all the way through the actual delivery of the well have access to that data or access to historical data that could be used from a planning point of view early on if that particular formation that is being drilled has been drilled before. So data historian with WITS-ML server, it stores real-time data, maintains the history, supports applications requiring data, and I've said before it can be at the company's location, or it could also be as basically a service cloud-based capability. Drilling applications, they're available to support the full drilling and completions life cycle. There's planning, drilling, and completions. I've talked about that a little bit. And applications utilize the WITS-ML and application-specific database for information. So it's really a combination. The WITS-ML is the real-time information, but there's additional entries or table entries in there for other aspects of it. So if I'm doing well planning, as part of the planning phase, I have to specify, well, how much casing I'm going to be using, what's the size of the casing, how much mud am I going to be using or I'm planning on using, and that information gets recorded in various database tables and is maintained from a historical basis. So the challenge we see is basically WITS-ML limitations. It's basically a data standard for drilling data only. It's also a data model for drilling data only. And so the requirements interface directly with rig instrumentation for data captured. That's what we would like to see the industry migrate to, leveraging OPC UA for that. Ensure data quality component for each data point. Right now, the industry itself has a real dilemma in that with the contracting of rigs and instrumentation on the rigs that they don't necessarily own, whether or not the data that they're getting from the instrumentation, what is the quality of it? They don't have any reference point for the last time that particular piece of instrumentation, that let's say it's a pressure gauge, they're getting data off of it and they're making decisions off of it, when the last time that was calibrated. So there's an issue with there. OPC provides some capability for that. There's also command and control capability. The industry wants to move to basically a demanning of the rig from a safety point of view, less people in harm's way from a dangerous type of a job that drilling a well is. And so being able to go ahead and leverage an OPC capability for that, a UA capability, provides a commanding capability so that you can get into a situation to where you can start moving people off the rig and doing remote operations. Alarms and vents, which basically OPC specification supports great. Security, also standardized data transfer across systems, and that's another real benefit from an OPC point of view. Limited opportunities for performance and excellence based on improving well planning, optimized drilling and completions performance, well data acknowledgement management, drilling process, workflows, benchmarking, and real-time remote operations and support. So the drivers for the change we see are the Deepwater Horizon, the Macondo well. All the industry is looking at that, looking at the risk and liability that took place there. It's a big hit from a BP point of view, from a financial point of view, and so all of the major players, the Shells, the Hesses, the other major companies out there, and looking at how we did things or how they've done things in the past, and looking for ways to go ahead and change that, provide a more safer environment for their people, migrating people off the rig. So there's also increased competition within the industry, and with that, being able to do more because of the increased competition and lower your underlying drilling costs are important. By lowering your drilling costs, and that gives you an opportunity to drill more wells. Talked a little bit about the environmental health safety challenges and regulations. A lot of regulations that are going to be coming out of the federal government. The industry's been trying to get in front of that. BOMER is the government organization that is basically addressing that. Better utilization and leverage of subject matter experts. The industry basically is growing due to basically the shale play here in the United States, the Eagle Ford shale play here in Texas. There's also up in the Dakotas, the Balkan play. And with all of this, there's an increased amount of actual drilling that's taking place. And so what that means is, from a subject matter expert, is they have a limited number of people with knowledge, and by having a real-time command and control capability, you don't necessarily have to send your expert out to the field to basically analyze something, look at something, or help with a problem or an issue that's taking place on a well. With real-time command and control, they can actually be in the control center, access information about that rig, work with the team that's there on site with the rig, and basically do an analysis and determine what the situation or problem is, and provide a solution to go ahead and react with it. Improved risk management takes place. Also minimize exploratory and operational costs. And that's a cost reduction of leveraging it. And maximize opportunities for project management and control. So what we see in the future is a OPC UA integration from the corporate office to the rig instrumentation and the rig subsystems. And so the rig components here basically would not have basically a serial interface at that point in time. They would have an OPC server that's interfacing with the rig instrumentation. We obviously have the communications leg. We would have a OPC server here that is basically interfacing with the remote OPC servers and having that data available. And then we'd have a set of drilling applications here that are interfacing with the OPC server. So what we see and where we're using InduSoft is basically here at the rig location for one place is basically today taking that serial feed coming from the MD tacos or the Paisans. We convert that into an OPC server and instantiate basically an InduSoft OPC server to provide data collection there at the rig. We basically also flow data over to an OPC-based, InduSoft-based server here from a historian point of view. And on the drilling applications, we're kind of at our infancy. One benefit from an InduSoft point of view is the visualization capability that's out of the box is very, very good. So there's a lot of things that you can do just right out of the box, but we're also working on some specific drilling applications at this point in time that is leveraging that capability. So from a future, we see OPC UA basically creating opportunities for improved optimized performance increased automation. So the idea here being that if you can take a manual process and basically convert that into a basically a automated procedure that has been fully tested, then you can basically implement that. So I think a parallel to that is from a historical basis is most of us today in interfacing with TCP/IP basically do instantiate an object or do what basically SCADA showed is it's built into the tool set. We never really get down to interfacing with the TCP/IP side anymore. And that's what you see from an automation point of view. Automation is really the creation of a capability that can be reused going forward and then possibly leveraged on. Also, opportunities for remote command and control, we see that growing. Increase awareness and knowledge in the decision process. So this allows basically a remote command and control and OPC UA allows the stakeholders at the corporation to basically have a better understanding of what's taking place on a rig and making decisions. Now, one of the interesting things from a post-mortem from Macondo was that the BP actually had real-time command and control that they were monitoring. They weren't doing controlling, but they were monitoring the activity on the well. The problem was they weren't staffing it from an 8 to 5, only from an 8 to 5 point of view, and the disaster actually took place after 5 p.m. And so in this particular case, now you're seeing more increased awareness and being able to have a command and control capability to where you're starting to monitor this data 24/7, or you're putting in some form of automation to monitor the data and raise the issue when you have certain things. And obviously OPC UA from a alarming point of view and InduSoft from a product point of view has a lot of capability there. Also knowledge management and sharing, as well as benchmarking of current practices. So the benefits are known. New drilling rigs are being OPC UA certified. As a matter of fact, Dr. Van Oort's vision for UT is to basically field a remote drilling rig that you basically just put supplies on it, and he will do a remote command and control on that rig from his basically an RTOC that he has there or is currently being built there at UT and in Austin. Also, downhole equipment will be being OPC UA certified, which means we'll have access now to the downhole drill packages, the MWD information or packages that are part of the drill string, and increased opportunities for obviously unmanned drilling. We talked a little bit about that, and implement changes that can be addressed and in a straightforward manner. So summary, basically we see the oil and gas industry kind of at a critical point in the development and implementation of the digital oil field environment. Obviously real-time data structures has evolved with a little overall design and structure to the underlying data management requirements. Current data standards based on a combination of proprietary vendor standards. And we see ever-growing volumes of data that required to facilitate decision-making. There are drivers for more efficient operations and data management support. So in conclusion, we see the OPC UA architecture that combines the functionality of the existing OPC interfaces and new technologies such as XML and web servers to deliver a high level of operational support, and it provides basically an integrated data foundation capable of handling increased data volumes while providing optimized and accurate information required for critical decision making. Questions and answers. Okay.
And let's see, let me go out here and take back control from you. At this point, if any of the participants or attendees have any questions, feel free to put those into the Q&A box in your WebEx session or in the chat window as well, and I will read those off to John, and we'll see if we can't get those answered for you. We had a few good questions this morning, and let me see if I can go ahead and get into those as well. Let me skip through here. Available resources. There was a question this morning, before this morning's presentation, about what available resources would you have as a partner of InduSoft to be able to promote or understand InduSoft a little bit better. First of all, you can download our product off of our website, and it has a 40-hour development environment and a 2-hour runtime, which you can then choose to license if you would so choose to. So it's a fully enabled demo application, so there's no restrictions as far as being able to enable drivers and communicate with PLCs and check performance and things like that. You can save your application, and it's not really restricted in any way. In addition to that, on our company website, you'll also find that you have the sample applications. We've got examples on there as well, and so literature. Let me in fact go ahead and open up the website here. We have literature as far as being able to download those. Let's see here under products, literature. We have data sheets on the product, the current product as well as the previous version. We also have a corporate brochure that has information in it. We have several different industry-related brochures, and then we go down in here and we have a mobile brochure that talks about our 3 different types of thin clients, as well as other different mobile opportunities that you have. And then we also have a business intelligence dashboard template that we offer, and there's a brochure on that. So a lot of good information as far as what you can use from InduSoft to either promote InduSoft or even learn about it yourself. And another question that came in was, what about using secure viewer clients and showing a different display on the client versus on the actual runtime? First of all, that's just inherent in the product, and there are several different ways to do what was asked, which is the ability to show some display or trigger a display on one of the thin clients. And one of the things that can be done is, if we go back into the development environment here, again, just by changing the screens on the client, that does not affect the main InduSoft runtime. But one of the things that can be done here under project tags, if we take a look at the different tags, by default they are server scope, which means they are synchronized between the thin clients and the main InduSoft runtime. So for example, if you have multiple thin clients and thin client number 1, let's say, changes a value, it writes, when it's set to server scope, it writes it back to the InduSoft runtime, then the runtime synchronizes that back out with the other 3 thin clients. If this scope on a particular tag is set to local, then each thin client has its own copy of the data, and the InduSoft runtime has its own copy value for that particular tag. And in a case like this, you can use a tag to trigger screen changes on the individual thin client if you would so choose. So that's an opportunity as well. So if there are any other questions, please again feel free to put those in the chat window, and we will answer those as we can. I'll get John included in those. And let's see, at this point I don't see any questions coming in, and nothing in the chat window, nothing in the QA window. So hopefully we did a good enough job. We got all your questions answered, and hopefully you understood what we were talking about. And John, I'd like to thank you again for participating in this. This is the, I think, 4th time I've seen this presentation. I learn something every time we go through it, so thank you very much. And thanks. And again, with no questions, I think I'm going to go ahead and end the webinar. But also, don't forget to fill out the survey when you get that, so you can get your free T-shirt. And feel free to check out our website, see the information, and join us on future webinars as well. And just as a quick point of reference here, I think the last slide that I have is how you can contact InduSoft via our websites. Emails at info@indusoft.com, at our Brazil office, Germany office, as well as you can always give us a call. We'd be happy to take your questions. And you can also look at us on Facebook, see us on Twitter, LinkedIn, as well as watch videos on YouTube or on our website as well. So thank you for attending, and hopefully everybody enjoyed this, and have a great day.